I think we can start naman na since recorded naman yung session. And mostly sa start, basically review lang natin or overview lang ng mga nagawa nyo na so far, I hope. So, share ko lang yung screen ko. Okay. Mhm. And so, sabi ni Jose, based dun sa past meetings, okay naman yung performance sa week 2 exercises. And then sa week 3, yung major problem nyo or major na challenge sa inyo is yung problem 3 over here, yung may absolute value na case. So, nag-post si Jose ng helpful hints sa Discord channel natin. Hopefully, na ma-incorporate nyo yun sa solution nyo. What I'll say is, you can try to visualize yung problem. Siguro mag-plot kayo ng number line. Ano nga ba yung mga cases nyo na kailangan tignan? Or ano yung values ni X and Y? Or ano yung mga scenarios kung kailangan ko matignan lahat ng combinations ng positive negative si X at saka positive negative si Y? Or baka kailangan lang naman natin consider yung case na what if pareho sila ng sign? What if different sila ng sign? So, pwedeng mabawasan natin yung number of cases na kailangan check. And baka mas madali silang improve that way. Well, either way, since lalo na sa proving based on experience, iba-iba rin kasi yung approach ng mga tao. So, I can't really say, parang walang singular way to help all the students. So, what we'll really need is yung kung ano na yung mabibigay nyo sa amin and we'll give our feedback on that. So, make sure we utilize yung uh, on these submissions basically for one-to-one. And ay, yung chinecheck ko naman yung mga ginigrade ni Jose, may feedback naman siya. So, uh, parang i-address lang yung mga binibring up doon sa comments. And then in the future din naman when I check your work, ganun din naman yung magiging setup natin. So, parang isipin nyo, lalo na yung mga nakapag 1-1-1 ng face-to-face, yung mga late na nag-take ng 1-to-1, you'll notice pag sa classroom, pag may exercise, you can always raise your hand and ask the SA or the instructor to give comments on your work. So, equivalent yung doon sa pag-submit nyo. And so basically, pag nag-submit kayo, you're raising your hand and then magko-comment kami sa work nyo. And then, continuous lang, iterative yung process hanggang makuha nyo na siya tuluyan. So, ayan, going back, ano nga ba yung ginawa nyo ng week 3? So, it's methods of proof. So, basically proving if statements are true or given a condition, ano yung given a proposition, I guess, kung tama ba yung kalalabasan. So, it will be helpful for us when we want to prove yung algorithms. Kasi yung first part ng course is about actually algorithms. And then, yung analysis ng algorithms, medyo hati natin into two. Yung first part ng analysis, yung sa week 2, which is yung complexity analysis. So, yung resources na kailangan niya. So, weeks 3 and 4, nakafocus siya kung tama ba yung algorithms or tama ba yung result or basically a way to predict yung result ng algorithms natin. So, I have here some examples. So, ito, I have two functions. So, yung first function, square 1, returns a times 2. So, similar lang naman din siya sa A times A. So basically, ginagamit natin yung actual definition ng square ng isang function. And then, so, medyo trivial siya kasi ito yung definition of square and may built-in function si Python for that. So, it is sort of trivially correct kasi ganun siya define. So, yung next dito sa baba, maybe at first glance, hindi siya mukhang square function. May multiplication pero walang it's not involving A. So how do we prove na tama siya or basically kung wala hindi ko nilagay na square yung pangalan, how do we know anong ginagawa ng function na to? So in proving it, lalo na may loop tayo na sinusundan dito, we first prove that the loop terminates and then identify a useful loop invariant na tinatawag and then prove that the loop invariant is invariant. Kasi yung sa step 2, it's basically a guessing step or you make a hypothesis and then sa step 3 is yung pag-verify mo ng hypothesis mo. And then lastly, yung loop invariant mo naman, it says something about the loop. So, hindi siya nag-say ng anything about the actual. Well, it says something, pero hindi siya yung result ng function mo. So, we show that at the end of the loop or at the end of all iterations, ano yung value ng loop invariant, and supposedly, meron dapat doon natin na-verify kung tama or ano yung ginagawa ng ating loop. So, focusing on this function, how do we say na nagta-terminate yung loop? Well, sa Python naman, pagka meron tayong for loop, mag-iterate siya over all instances or all elements doon sa list or doon sa range na binigay mo. So, medyo trivial lang naman na, yeah, since for loop siya, sure tayo matatapos siya. And then, yun next is identifying a loop invariant. So, ano nga ba ang loop invariant? So, from the name itself, it's something that doesn't vary doon sa loop. For example, dito, we can say na I is always less than 8. Kasi yung range A will contain numbers starting from 0 hanggang A minus 1. So I will be always less than A. So actually yun yung proof na invariant siya kasi lagi siyang true after every iteration ng loop. But at the end of it, ano yung masasabi natin doon sa algorithm natin? Parang wala tayong masasabi about the result ng algorithm. So while it is true na si I less than A is a loop invariant and na-prove natin na invariant nga siya, it's not really useful for us. So maybe we need to look at another loop invariant. So basically, madaming loop invariants na pwede i-consider. So maybe in this case, we can consider itong line na to. Temp is this expression right here. So technically speaking, since that's how we define temp to be, loop invariant siya. Pero ano nga ba yung masasabi natin dito at the end of the loop? So parang medyo wala naman. So hindi natin masyadong. So yung loop invariant can be somewhere na something na wala explicitly dun sa code. You have to look at the behavior ng code. So a good way to do that is to visualize what the code is doing. So let's say I is equal to 0, ano yung laman ni temp? So temp would contain 2 times 0 plus 1 or 1. Then sa next iteration, I will contain 1 So temp natin is yung previous value niya, 1, plus 2 times 1 plus 1. So 3. So may 4. And then when I equals 2, si 4, mag-add tayo ng 5. So what you notice here is, ano yung value ni temp? So sa I equals 0, temp is 1, which is a perfect square. Then at I equals 1, ang value ni temp ay 4, which is also a perfect square. And then 2, at I equals 2, magiging 9 siya, which is also a perfect square. So maybe we can predict na at any given point I, yung temp natin will contain I plus 1 squared. So true siya for these first few values. Well, for now, maybe hindi pa tayo sure kung tama talaga siya. Pero tama siya for the first few values. So ang step lang naman na to is making a guess or making a hypothesis. So kahit hindi pa tayo sure, okay lang naman. Since sa step 3 naman tayo magiging sure. So it's probably a loop invariant. So we have to check. Kaya tayo may step 3. So yung loop invariant natin, let's say temp is equal to I plus 1 squared. So we want to prove the loop invariant. So in this case, since parang nag-iterate tayo, di ba? So doon sa mga methods of proof natin, whenever we have something uh, true for n equals 1 and then 2 and then 3 and etc., usually we'll be using the inductive proof. And then yung base case natin is already true kasi yung actually yung first case natin dito when I equals 0. And then since na-prove na rin natin siya with I equals 1 and 2, pwede na actually tayo mag-strong induction. So although hindi naman siya necessary for this case. So ayan. So we know that the loop invariant is true for the base case. So now we go to the inductive step. So we need to show that in the next iteration, yung next value ni temp is equal to the next value ni I plus 1 squared. So since ito yung magiging focus natin, tanggalin ko muna yung other parts na nasa slide. So we need to show this one. So ano na ba yung alam natin? So at the next iteration, we know because of this definition natin ng temp, yung next na value ni temp is yung first na value ni temp plus 2 times I next plus 1. Pero si I next, given yung nature ng loop natin, we should know that yung I next will be equal to I plus 1. And then, so ito, naging I plus 1. So ginawa ko lang mathematical na formula para mas madaling tingnan. And then si temp, because this is proof by induction, we have yung parang inductive assumption natin na temp should be equal to I plus, and sa yung initial loop invariant natin, temp is equal to I plus 1 squared. So, ayun. Okay. Na-off lang ako kasi wala yung next dito. Tapos naging plus 2 siya. Although pareho lang naman. So, because this is proof by induction, we can assume that temp is equal to I plus 1 squared. And then si I next, by the definition of I, which is yung next element dun sa range A, I will be I plus 1. So yung next dito is expand ko lang yung squared term and then distribute ko yung 2. And then I can add yung like terms, si 2i and 2i here, tsaka si 2, 1 at tsaka si 1 doon. So temp next would be equal to I squared plus 4i plus 4. Now, I assume naman na dumaan na tayo lahat sa quadratic functions. So we can factor this to I plus 2 squared. But since we know si I next equals siya sa I plus 1, excuse me, pwede kong kunin si I plus 1 dito, and then we get I next plus 1 squared. So, using yung inductive assumption natin, we've proven na yung temp next is equal to I next plus 1 squared. So, na-prove na natin na invariant nga yung, or yung hypothesis natin, we prove na totoo siya and consistent siya at after every iteration ng loop. So, uh, yung pag-prove naman, so we proved the loop invariant pero hindi pa natin napo-proof or na-show yung functionality ng algorithm, which is why meron pa tayo yung last step, which is yung checking yung termination na value. So at termination, we know that I equals a minus 1 kasi yun yung last value sa range. So when I equals a minus 1, si temp, alam natin si temp equals siya sa I plus 1 squared. But si I, at termination, inequate natin sa a minus 1. So when this becomes a minus 1 plus 1, may a squared. So by this, by checking the termination value, we can verify or we can show that yung result ng algorithm natin, square root of a, is a squared. So, yay. And then, nung tinitingnan ko yung sa lecture materials sa uli, medyo may difference lang dun sa terminology. Usually, tinatawag na initialization yung base case dun sa proving ng invariant, tapos maintenance yung tinatawag sa inductive step. So, pareho lang naman yun. So, difference lang ng terms na ginamit. Pero, hopefully, you see the point naman. So, may questions ba so far? I just have one other example ng medyo mas complicated na algorithm. So, if may mga questions sa process, I think you should tell them now kasi mas magiging mas mabigat yung proof natin sa next part. So, kailangan ng konting mental gymnastics. Ika nga. Yeah, so since I don't think may gusto magtanong, I think I can move to the next example. So, familiar ba kayo sa Sieve of Eratosthenes? So, I guess kung gusto niyo makita visually kung anong ginagawa niya, you can make a quick search. And ano kung may magandang gift to sa Wikipedia. So, kung nakikita niyo yung sa right side dito, so basically lahat ng multiples ng mga prime numbers tinatanggal niya doon sa isang list. And then, basically it's a way for us to get all the prime numbers less than a certain range or given a certain range. So in this case, this finds for all primes below 121. So, going back, doon sa slide, this is my own implementation ng Sieve. So, what you might see online may be slightly different or maybe completely different since medyo unoptimized siya pero hindi siya optimized so that mas makita natin yung what I think is one more simple na implementation na makikita. Madi-demonstrate natin yung pag-proof ng algorithm. So, oops. What you'll see here is yung ating algorithm contains 2 while loops. So whenever this happens, kailangan natin i-separate yung dalawa. So usually we'll start sa innermost na loop kasi usually necessary yung makukuha nating conclusion or yung termination value for the inner while loop, and necessary siya to prove yung outer loop. So we start dun sa gitna ng while loop. So naka-shade out yung other parts ng algorithm. So first, ano yung proof na magte-terminate siya? So given the loop, either si J may increment siya by 1 or si array, mababawasan siya ng element. So yung pop operation, basically, itatanggal lang natin yung element at the index J. So pag nag-pop tayo, magdi-decrease si J, so J stays the same, pero yung length ni array decreases. So after every iteration, J plus 1, either J increases or len decreases. So we can say na eventually magmi-meet sila and mag-end yung loop. So we have our proof of termination. So next is we want to identify a loop invariant. So of course, madami tayong choices, pero we want that loop invariant that can help us describe kung ano yung ginagawa ng algorithm. And pag in-evaluate natin at termination, we have something useful, or we get some useful information out of it. So let's visualize siguro kung ano yung mangyayari. For example, here we have a array from 2 to 13. So at the start, let's say si I initially nakaturo siya sa first index 0, and then J is equal doon. So yung next na gagawin is i-check kung J plus 1 is less than yung length ng array. So that is true. So yung next na gagawin is mag-increment si J. And then si J, i-check niya is 3 modulo 2. So yung basically ang ginagawa ng condition na to is to check if hindi zero yung if zero yung modulo. Kasi if ang zero means false, so pag zero yung result nito and inanap natin siya, naging true yung overall na statement. So ang sinasabi lang nito, if walang remainder yung Rj over Ri, we pop the element. Well, in this case, may remainder. 3 divided by 2 has a remainder na 1. So we skip yung nasa loob ng if statement and we move on doon sa pag-check ulit ng ating condition ng loop. So on the next iteration, si J mag-move sa next index. Now, si 4 divided by 2 doesn't have a remainder. So, ayun, magpo-proceed siya doon sa loob ng if block. So, magpa-pop yung nasa index J. So, by popping, mawawala yung element na yun. And then, mag-adjust yung ibang elements. And then, we move back one step. Since si 5, wala pa tayong alam kay 5. So, mag-move back siya by one step. So, sa next iteration, si J magpo-point na siya kay 5. And then si 5, since hindi siya multiple basically ni 2, or may remainder siya when we divide by 2, we proceed doon sa next element. And then, we can predict na since si 6 ay multiple ni 2, or when we divide 6 by 2, walang remainder, mawawala lang si 6. And then, the next iteration, titignan natin si 7. And then si 7 will retain. And then sa next iteration naman, since si 8 yung nasa tabi niya, we can predict mawawala lang si 8. And then, after nung next iteration, mag-move si J kay 9. Then after nung next iteration, mawawala si 10. And then so on and so forth. So, ano yung nanonotice nyo nangyayari? So usually when we work with arrays, tapos nag-increment tayo, we can usually split the array into two parts. So yung first part dito, na nadaanan na ni J, we can say na pag meron tayong nadaanan na elements na multiple nito, tinatanggal natin siya. So we can say na yung elements dito, wala siyang multiples na 2. And then yung nasa kanan, wala tayong masyadong information. Pero itong fact na to na nakapansin natin, it should be enough for us to make a useful na loop invariant to prove. So the elements from I plus 1 to j plus 1, note lang na sa notation na to, si j plus 1 hindi kasama. So yung last element ng array na to, or yung slice na to, is hanggang index j. Does not contain multiples of yung element I. So I plus 1, that starts at 3, hanggang j plus 1. So si j plus 1 hindi siya kasama. So hanggang 3 hanggang 9 are not, does not contain multiples of the element at I. So we want to prove that. So for the base case at j equals I, so since yung boundary ng ating loop is same yung start, same yung stop, and yung stop hindi siya kasama doon sa slice, technically ito ay empty na array. So an empty array will not contain multiples of any number. So that is trivially true. So okay na yung base case natin. So nasundan naman yun. So basically yung slice na to will just be equal to an empty na list. So since empty siya, wala siyang multiples of any number. So as long as actual na number si Ri, this would be true. So next is yung inductive step. So basically we want to prove na from I plus 1 to j nu plus 1, it does not contain multiples of Ri. So how do we look into this? So after every iteration ng loop, we can say may dalawang cases. Either dumaan tayo dito or not. So yung two cases natin is that when yung modulo operation natin results to 0 or yung modulo operation natin results to non-zero number. So when zero yung modulo operation, we can say na yung new j, since nag plus 1 tayo dito tapos nag minus 1 tayo dito, new j is equal to j. So basically hindi gumalaw si j. So since we're looking at the same na slice ng array, we can say that the loop invariant is still true, or it still holds, since yung inductive assumption natin, or we assume that this is already true for for j equals yung j na old. So when yung bago na j equal lang dun sa naunang j, it's still true. So this is okay na. So now we need to prove yung second case na hindi siya equal to 0. So what happens when we go here? So in this case, si new na j equals siya kay j plus 1. And then we also note that yung bagong slice natin, ito, is equal to r I plus 1 to j plus 1 plus yung element at index j. So basically what this says is yung bagong range or yung bagong slice ng array na gusto natin tingnan is dinagdag ko lang yung jth element para maging equal siya doon sa bagong list. So, alam natin na si Rj, hindi siya multiple ni Ri. So, how do we know that? Because this condition should be true. So, if this condition is false, yun lang yung only case na multiple si Rj ni Ri. So, yeah, since naubusan ng space. So, since ito yung initial natin na list. So, this is yung initial na slice na alam natin na walang multiple ni Ri because it is yung part ng inductive na step. Now, since we know na walang multiple ito ni Ri, then adding Rj na alam natin hindi multiple ni Ri will not change this. So meron akong initial na list, wala siyang multiple ni Ri, dinagdag ko si Rj na hindi multiple ni Ri, so yung bago kong list should still have no multiples ni Ri. So basically ito yung nakita natin kanina sa visualization with more words basically. So which is technically what proving is in my opinion. So, thus, yung bago nating slice, so from Ri plus 1 to J nu plus 1, does not contain a multiple of Ri. So, the loop invariant holds, or the loop invariant is true in this case. So, true siya dun sa first case, true siya sa second case. So, we can say that this is true in all cases. So, excuse me, we have proved that yung loop invariant natin is indeed a loop invariant and it is true for all instances or for all iterations ng loop. So yung the last step is for the inner loop, last step for the inner loop is to check ano yung value niya at termination. So at termination, si j plus 1 is less than yung length ng array, which basically means from I plus 1 hanggang sa dulo ng array. So familiar naman kayo when we make slices sa Python. If kailangan nyo ng konting example, let's just open this. Kita ba? Or masyado mali. Okay, so Python. So let's say I have a list 0, 1, 5, 6. When I say I make a slice, kung wala mag-start ako at I equals 2. So starting at index 2, makukuha ko lahat hanggang sa dulo ng list. Tapos when I say 2 hanggang 6, so 2 hanggang 6 lang, ay 2 hanggang 5 lang, hindi kasama si 6. So hopefully walang masyadong nalito dun sa notation ko on slicing. So sinundan ko kasi yung convention sa Python. So hindi kasama yung dulo. And then if walang nilagay na number, hanggang dulo siya. And then conversely, pwedeng wala yung isang side, meron akong dulo. So from the start ng array hanggang 6. So baka maging helpful later. So ayun. So basically elements na yung elements na nasa kanan ni I, wala siyang multiple doon. So that would be something to note when we analyze yung outer na loop natin. So yeah, let's move on to the rest of the algorithm. So we need to prove na magta-terminate itong loop na to. So you notice here, after each iteration, I is incremented over here. So eventually, since finite value lang naman yung length ng array, eventually, ma-reach ni I yung value na mag-end siya. So that is our proof of termination. Now, for a loop invariant, of course, you always start with the visualization unless you're feeling lucky na kaya nyo mahulaan agad. But anyway, ayan, we start with an array na contains yung element starting from 2 hanggang n. So note lang na this operation just makes the range an actual list. Kasi if you notice here, pag ginawa kong range hanggang 2 to 10, pag pinrint ko si array over here, ang lilitaw is range siyang ganyan. So parang hindi siya list. So in order to make it a list, so in order to make it a list, meron tayong unpacking na ginagawa. So in order to make it a list, nilalagyan natin siya ng parang unpacking na symbol. So whenever we print yung array now, actual na list siya. So yun lang naman yun. So yeah, so this first line makes a list. This next line starts I at index 0. And then while I is less than yung length ng array, which is true, we just proceed with the loop inside. Now, since inanalyze natin yung naman ng loop na to. So ang gagawin niya, lahat ng elements sa right ni I, tatanggalin niya lang lahat ng multiples ni element na kay I. So what happens here is that lahat ng multiples nito mawawala doon sa list. So, next slide. So we just remove all the multiples of Ri. So now that inanalyze na natin yung inner for loop, madali lang parang kaya na natin siyang i-treat as a single line. Kung ano man yung nakuha nating result dun sa termination, yun na siya. Which is why inuuna natin yung sa loob. Kasi mas madali yung analysis natin yung nasa labas. So now that since we know na ang gagawin lang naman ng commands na to is remove all multiples of this element here or all multiples of 2, mawawala lang lahat ng even numbers. Now, dun sa next iteration, yung next step ng loop is mag-increment si I and then dadaanan niya ulit yung loop. And then yung loop, tatanggalin niya lahat ng elements ni 3. And then next is matatanggal lahat ng elements ni 5. So basically matatanggal si 25 over here. So a couple of observations. So yun nga, si array natin or si R nagsa-start sa 2 and then i-increase siya. And so something to note later yan sa proving. And then si R5 or an element at index I is not a multiple of any element before it. Kasi lahat ng multiples ng elements before it, tinanggal na natin sa list. So, ito yung magiging basihan natin for our loop invariant, which is, or in other words, since hindi ako multiple ng elements before sa akin, so yung only factors ko would be myself and 1. So, yung element natin at index I is always prime. So, a valid or maybe a sensible na loop invariant is that from the start of the array hanggang index I, it would contain all the prime numbers less than the number at index I. So, basically here, the saying, yung list natin before this number 5 contains all the prime numbers na less than 5. So, Ayun, pwedeng skeptical pa kayo ngayon kung totoo siya or hindi. But it's what we're going to go with and then ipoprove natin by induction. So, yun, nire-write ko lang dito. Yung base case natin is when I equals 0. So, array, yun at index 0 is 2 based dun sa definition natin. And then yung array starting from the start hanggang 0 is an empty na array. So, since we know for a fact na there are no prime numbers less than 2, if we don't consider 1 as a prime number, so walang prime number na less than 2. So, yung ating loop invariant is true or is true for the base case. Now, dun tayo sa mas mahirap na step, which is yung inductive step, na we prove that after every iteration, so basically, yung I, nilagyan ko na ng subscript na I next. And then, it contains all the prime numbers less than yung array I next. So, ayun, something to note, I next is always I plus 1. So, yung slice na to is equal to R colon I plus yung Ri. So, ang titingnan lang natin, so basically what this says is, because this is proof by induction, we can assume na si array hanggang element I or hanggang before element I contains all the prime numbers less than Ri. So, ang kailangan na lang natin i-prove na si array element I na idadagdag natin or si array element I na idadagdag natin to get this slice should be a prime number na less than yung array next. And then since we have this adjective na all, we also need to prove na walang prime numbers between this and this. So na-gets lang naman yun. So usually when your algorithm involves loops, usually madalas natin makikita to na meron tayong initial na slice, dadagdagan natin ng isa pang element, and then kailangan natin i-prove na totoo pa rin yung loop invariant natin. So sa mga sorting algorithms, usually ang loop invariant is a certain part of the array is sorted. So, pag nagdagdag ako ng isa pang element doon, given the nature of the algorithm, sorted pa rin ba siya? So, in this case, meron akong list of prime numbers. Magdadagdag ako ng isang prime number, or magdadagdag ako ng isa pang number. And we need to prove na yung resulting na list natin still contains all the prime numbers na less than no next element. So, moving on. We know that yung elements ni array, so kung may nalito lang, tinanggal ko lang yung sa taas na. We know that yung elements ni array is increasing because that's how we defined it. So we're sure na yung array at element I is less than array yung element at I next, or in other words, this is also I plus 1. So we're sure about that. So we can then, so parang medyo i-check na natin yung part na to na less than siya. So next is we have to prove na prime number siya. So we start with array I, or yung element at index I is not a multiple of any element before it. So yung reason for that is because of the inner loop here. So going back, when we terminated yung termination ng inner for loop, ay inner while loop, is that, so yung element ko at index I does not contain, and so yung So yung array doon sa kanan does not contain multiples of array I. So when we get here, we can say that array I is not a multiple of any element before it. So parang medyo binaligtad lang natin yung statement. But it's still true. So this is because of yung loop. So nawala lang yung arrow. So since we know lahat ng elements before I is a prime number, array I is not a multiple of any prime number before it. So yung inductive assumption natin. So since hindi siya multiple of any prime number before it, we can say na yung array I is prime. So sa mga mas well-versed sa mathematical proof, I guess this might look like a jump, pero for the purposes of 1-2, I guess this would be enough for us to say na yung element natin at index I is prime. Since lahat ng elements before it ay prime numbers na less than sa kanya, and note, lahat ng prime numbers na less than sa kanya is basically not a factor since hindi siya multiple. So if a number is a multiple of another number, basically if A is a multiple of B, then A and then B is a factor of A, di ba? So for example, since 6 is a multiple of 2, 2 is a factor of 6. And lahat ng may multiple kay 6 ay factor ni 6. So if walang may multiple sa'yo, wala kang iba pang factor. So, and since dinaanan natin lahat ng prime numbers, or sure tayo lahat ng prime numbers na mas maliit sa'yo, hindi ka multiple, we can say na ikaw ay isang prime number. So, ayun. So, we can say na yun nga, prime number siya and less than siya dun sa array next. So, yung next natin kailangang tingnan is that wala tayong na-miss out na iba pang prime numbers in between. Since, di ba nagre-remove tayo ng elements doon sa list. So, excuse me. So, nagre-remove tayo ng elements doon sa list. And then, since we know na, so we have to prove that walang prime number exists between yung initial natin na list tsaka yung idadagdag natin na number. Now, since we know array, yung array natin initially contained all the numbers from 2 to n-1. And then yung inner loop natin only removes elements that are multiples of other elements. So we're sure na hindi tayo nagtatanggal ng prime numbers. So if andun kung may prime number man sa gitna nila, hindi dapat siya matatanggal. So lahat na natanggal between these two elements should be composite numbers. So no prime number should be removed. So it contains all the prime numbers doon sa slice na gusto natin. So ayan, that will be the proof of the loop invariant. hopefully nasabayan nyo. Although I'm not sure din na describe ko siya in good detail, pero hopefully nasundan nyo. So at termination, we look at it. Si array I would end at least n minus 1 or smaller. Kasi minsan si n minus 1 ay hindi siya prime number, so wala siya doon sa list, so hindi siya madadaanan ni Ri. So we can only say it as an inequality. So what we also know is that array I contains all prime numbers less than Ri, but Ri is n minus 1. So yung array natin from the start hanggang index I contains all the prime numbers less than n minus 1. Then we know that the element at array I is a prime number because of the inner for loop. Then we can say that at the end of the iteration, yung array natin contains all the prime numbers less than n. Now, since kung meron man skeptical sa inyo, kung totoo nga siya, so I have it loaded here sa so nandito siya sa program ko. Then and so basically kinall ko lang si Sieve hanggang 100. Sige, sino gawin natin 120. Ang ginagawa lang naman nito is nilalagay yung tamang spacing tapos every 5 digits siya. So when we run it, hindi makita. So yeah, we have all the prime numbers na less than 120. So ayun, pwede nyo pandagdagan. Say 1,000. So more or less prime numbers dapat lahat to. Yeah. Now, ayun, we prove na tama siya. So what's next is i-prove or i-identify yung time complexity niya. Now, medyo complex to since medyo kailangan natin alamin kung ilan yung prime numbers na less than a certain number to get the number of iterations. So let's say n is equal to 100, we have 25 numbers or 25 prime numbers less than 100. So yung loop na to will run 25 times. And then yung inner na for loop natin will run at most yung length ng array. So parang n times the number of primes. So and hindi naman magbibigay ng ganun ka-vague na time complexity na question. Pero if ever anyone is interested in calculating yung time complexity nito, then that's that. Kaya mahirap so may nagtanong kung or may nag-point out na nag-change yung length ni array. So that will be why it will be very hard to determine yung time complexity ng function na to kasi nagbabago nga yung length ni array. So kung gusto mo lang ng worst case boundary, you can always assume na yung length ng array is hindi nababawasan. So that will be your worst case. Although yun nga, hindi siya yung sometimes depende sa programmer or depende dun sa application, it might be enough to just have that boundary. So kasi kung dito in this case, if si length ni array dito is n and then length ni array dito is n din, n squared siya. So kung gusto mo lang naman kung at the worst case, n squared siya, and you're sure na hindi to magiging less than n to. And most probably, parang log n pa nga ata or something similar doon. May n log n siya na operation. So, parang, uh, ayan, it depends na lang if important for you to know na n squared ba talaga siya or not. Or at least alam natin na it's better than n squared. So, yun lang yung masasabi natin dito. So, for actual questions naman, kuwari sa mga quizzes and din sa exams, wala naman ganito ka-vague or may ganitong klaseng computation. So, yeah, it's an additional challenge to accurately, or it's very challenging to accurately determine yung time complexity for this specific na algorithm. Pero yun, titingnan mo pa rin kung gusto mo talaga tingnan. Okay. And so I think yung pinaka-optimized na sieve of Eratosthenes yung n log of log n. Kaso yung sa akin kasi hindi siya optimized eh. Notice here, pwede ko itong gawing square root ng length. And then, kung titignan mo yung sa sieve dito, sa Wikipedia, hanggang 120 lang naman siya. So, by the time na mag-reach siya ng square root of 120, which is around 11, hindi na siya nagtatanggal ng elements. Kinukuha niya na lang. So, pwede mo lang hindi daanan yung inner na for loop pagdating nun. Pero ako, dinikit ko pa rin siya kasi ayun, mas maganda yung itsura ng termination value. Although yan. Mag-iiba lang naman dun yung magiging less than square root of n. Tapos, kailangan pa natin i-prove na since tinanggal na natin na elements na less than array I, yung next na composite number is yung value squared. So, yeah, may additional steps dun sa optimization. So, yeah. Basically, yung one of the pinaka-optimized na version ng algorithm and log of n. Okay. Any more questions? Yeah, so for week 4, yung exercises nyo, I think focuses on yung analyzing yung isa pang yung sorting algorithm. So, merong tatlong code snippets dito na kailangan tignan yung loop invariant. And, ayun. So, not sure kung meron tayong easier way. Kasi, when we solve this, yung parang critical step is yung identifying a useful na loop invariant. And then, ang mahirap naman if meron kang inassume na loop invariant tapos hindi siya yung hinahanap namin and then hindi siya masyadong useful at the end of it pero pinrove mo siya, sayang naman yung effort. So, tingnan ko if we can find a way na parang ipa-check nyo muna yung loop invariant bago nyo siya i-prove. Siguro, ayun, you can send us yung I guess yung sample or bago kayong mag-go into the proving, pwede nyo munang isend sa amin ni Jose kung ano yung loop invariant nyo before actually solving it. So, ayun naman, something to help you para hindi sayang yung effort when it comes to loop invariants. Kasi it really takes time para masanay na makahanap ng appropriate na loop invariant. So, huwag kayong masyadong ma-down if hindi nyo siya makuha on your first try. Kasi, ganun din naman kami before. So, lalo na now na since hindi lang naman ito yung first time na ituro ko yung subject. So, parang medyo gamay ko na talaga kung ano yung loop invariant na tinitignan doon sa mga examples. So, hopefully, okay lang yung sa inyo, yung process. Wanna hear, I think, so, sana napakita ko ish yung parang process ng pagtingin ng loop invariant na yung una mong pili-piliin, okay lang kahit hindi siya yung tama. So, it really goes through a process. So, wag lang kayong mahiyang mag-try, basically. So, ayun. Any questions from the class? Going once, going twice. Okay. I guess that's the end of our session for today. I hope may natutunan kayo. If you have any questions, email, Discord, kung mahanap niyo yung Facebook ko, pwede niyo akong chat. Kung mahanap niyo yung Twitter ko, pwede niyo akong DM. Ayan, yan ang bahala. So, maraming salamat and I'll see you next time.